This episode is a direct sequel to the previous episode in the PDP-11 series, which is titled 1980s Networking is Hard. And as the title implies, we tried to get this PDP-1144 onto my local network, and we failed miserably. If you want to know all the lore that led up to this episode and what we're working on today, I highly suggest going to check out that one. I mean, it's a pretty good episode, I think. You know, I'm kind of my biggest critic. I think every episode I make is hot garbage and could be better, but that one turned out all right. So, but if you don't want to check it out, essentially what happened is we have two different networking cards. And one of those cards is the DELUA, or I'm almost certainly pronouncing that incorrectly because I got dozens of angry comments in the previous episode of people trying to correct my pronunciation of both this card and its predecessor, and I'm sorry, man, like those neural pathways have been made for years and it's really hard to unlearn pronunciation neural pathways. I'll try, but I'm guaranteed to pronounce it incorrectly for the rest of the episode, so please don't get too angry. But the DELUA here is a 68K based network interface card for a unibus system, which means it should work perfectly with our PDP-1144, except this one is broken. Every time we plug it into the 1144 and power it up, the little LEDs start to flash like it's going through its self-test, and then it immediately halts, giving us the LED error code of a RAM checksum error, which means that we think the problem is located somewhere right over here where all the DRAM is, and I tried to run, I didn't have the right XXDP test for this card, but I had the one for its predecessor, and I tried to run that on this card, and it kind of pointed us maybe towards bit 0 being bad, so I changed out the D0 DRAM on here. That didn't fix it. I changed out the D15 DRAM on here, and that didn't fix it. I was thinking maybe, you know, the words were reversed. I also tried changing out D7 and D8, thinking that maybe byte order was swapped around. That also didn't fix it. So we're just constantly stuck at a RAM checksum error, which means that we're gonna have to sit down and troubleshoot this properly. But like I said, there's two network cards that we have. And the other board is the DEUNA or DEUNA. Most assuredly, I'm pronouncing that incorrectly, but this is a two-board set that is the predecessor to the DELUA. Now, architecturally, I think they're pretty much the same, except that the DELUA uses a 68K as a monoboard microcomputer to shrink all of this logic down onto a single board. But this one is like no slouch either. This has a full-fledged CPU on it called, I believe, the T11 CPU that was built by DEC. And I mean, like you can see, like there's PALs and ROMs and RAM, there's all sorts of wild stuff going on this two-board set. And when we plug it into the PDP-1144, it gets much further along before it fails as well. It gets through all of its internal self-checks, passes everything, and appears as if though it's fully functional until we try to use it. And when that happens, we get an error that says the DNI bit is not set. And DNI stands for interrupt done. So essentially the PDP-11 asks this to do something, and when it finishes doing whatever it's doing, it's supposed to set that DNI bit, and the PDP-11 is never seeing that bit get set, so it just falls into this weird infinite loop that we can never break out of. So which one of these two should we troubleshoot? And that's a decision I've been really struggling with making because the DEUNA is incredibly complex. It's got that T11 CPU on it that we know nothing about, and really trying to track down that DNI bit is going to be incredibly difficult. But we have the full technical manual for it and a full set of schematics for it. So I think it's doable, just gonna be a little bit of time consuming while we try to figure out what's going on. Now conversely, the DELUA is a lot simpler of a card. I mean, it's essentially a 68K monoboard microcomputer or a single board computer, and that shares a lot of very similar architecture with many others out there. And really, it's just got a RAM fault. So we can just kind of focus on that DRAM section and work outwards from there until we figure out exactly what's gone wrong. The only problem is that we don't have any documentation for it. There is the user's guide, which of course we've found, but the technical manual and the schematics have been lost to the sands of time. So we either need to start reverse engineering things by beeping things out, or maybe putting some custom ROMs in it and letting it do the diagnosis itself and tell us what's gone wrong. Now that's something that I would absolutely not be capable of, but I have a good friend over on the Discord by the name of Fletto666, and they are an absolute 68K wizard. They cracked the case on the FPS 3000 VersaBus monoboard microcomputer that's in it, and they got nerd sniped when they saw this thing. And so I think we might have some diagnostic ROMs that we can drop into this to test and see which RAM chip has gone bad. So I think what we need to do is burn those ROMs, drop them into the DELUA, pop that into the machine, and see if that gives us a foothold to start troubleshooting it. And if we get completely and totally lost on the DELUA, maybe we will retire it and focus on the DEUNA. But I think for now, the DELUA is the right call. So we're going to program the new ROMs using the T48. I think that's the right model number here. My good buddy MX Shift sent me this after I blew up my previous one. So thank you, MX Shift, for saving us there. But the ROMs that we're going to program are these guys right here. These are AT28 PC64s. So I'll just go ahead and take one here, and I will drop it into the programmer there. And then on the laptop here, the application to program it is called MiniPro. So I'm going to change over to that directory here. So I'll do ls. The ROMs that Fletto has made are titled DELULU. You know, because. So it's DELULU RAM high.bin, DELULU RAM low.bin. So we're going to start with the high one here. So it's going to be MiniPro-P AT28 PC64 -S-W for write. And then the file is DELULU RAM high.bin. So then we'll just go ahead and hit enter on that. Erasing, writing code, verification okay. So that's the high one. Now we just got to do the low one. So I'll just pop that one out, pop the low one in here, make sure I get pin 1 in the right orientation. We'll just go ahead and hit the up arrow and change high to low and hit enter on that. Writing code, verification okay. All right, I've got the high byte in. This one is the low byte, and my little hook tool is, boy, what a lifesaver here. These things are crunchy. These ROMs have never been out of their sockets, I think. But, you know, like that clearly wasn't the problem that we were having. We were reading the ROMs just fine. All right, there we go. Low byte, high byte in. Just got to get this plugged into the machine now. And there we go. Lock it down. And the only thing that Fletto's code should have changed is the behavior of these LEDs here. Now they should flicker a very specific pattern. Let's see if they do that. Maybe I've got something wrong here. We'll give it a shot. Power coming up. They are indeed flickering a very specific pattern. That is awesome. That means that they work. It also means that they found a fault. So what do those LEDs mean? Well, the way that Fletto modified the ROMs is that everything is intact, except for that whenever it detects a RAM fault, instead of just kicking off with a code that we look up in the manual to say that there was a RAM checkerboard failure, it actually puts out a very unique pattern to let us know which RAM chip failed the checkerboard pattern. And so that pattern that Fletto's ROMs kicks out is 1111000 followed by 0000111. This kind of lets us get our bearings. And then it gives us a 010 and then a 4-bit binary value that tells us which RAM chip went bad. In this case, 0101, which stands for 5. So D5 is our bit that is bad, and the way that the DRAM here is laid out is these two ones on the bottom are parity, and then we count up on the right. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, all the way up to 15. So 7655 should be this one. And we can verify that that is D5 by putting the digital multimeter here on pin 64 of the MC68000 here, which is D5, and that should be right. Yeah, there it is. Hear it beeping. So that chip right there is the bad 4164. We need to remove that, replace it with a new one, and hopefully that fixes our DELUA. All right, D5 has been replaced. I did lift a trace pulling that one out because it's just a nightmare, but I did a quick bodge and I think everything's okay. So we're gonna take a look at these LEDs here. I think if everything passes, they should just go off and stay off. So let's find out. Let's go power coming up. Oh no, looks like we have maybe one more bad IC. Yeah, because there's the pattern. And then it says 0110. Dang. All right, D6 has been replaced. So let's hope that there's no more that are bad. All right, power coming up. Oh! I think it passed. We're stuck at that now, which is a different one, but that could be because we're at ODT and we're not hooked up to the network. All right, check this out. These are the LEDs that we got right here, and 0111 are the ones that we care about. That lines up with this one right here, 0111. That's NI and Unibus halted state. I think at this point we need to start plugging things together and see if my router will dole out an IP to this thing and maybe the DELUA works. I'm cautiously optimistic here. I've got the cable plugged into the DELUA, that plugged into an AUI and MAU, one of the things that goes from the 15 pin to the Ethernet cable. The Ethernet cable is plugged into my router. That router is 10100 capable. So let's give it a shot here. Power coming up. My rainbow should act. Yeah, there we go. Console version 3.40C. Halted at 165714. This is all business as usual. So we do a B space DM to boot from the Fujitsu drive that I have in there, the SMB drive that I've got in there. This takes about 15 seconds before we get any sign of life out of it. It is the longest, most harrowing 15 seconds ever. But as soon as it says, there it goes, RSX 11M Plus version 4.6, that's booted off of like real deal spinning rust. That's pretty exciting. All right, so we're gonna let this go. It's gonna ask me a question about the date and time. Yeah, here we go. So the time is currently 00:32. And the date is, I have no idea what day it is today. What does my laptop say? 11-AUG-2026. All right, we'll see if it takes that. It did. Okay, so start DECNEC, we're gonna hit yes on this. Start TCP/IP, we're gonna hit yes on this. I don't have a crash explanation. So now it's gonna run through the boot process. Now we just gotta sit here and wait and see how it goes. All right, we didn't even make it as far as set NCP sys. We kind of got held up at con online all. Not even sure what that means, if it's a network thing or not. We've never gotten held up at this one before, so. With the advent of a little bit of sleep, that con all message that we were stalling on was stalling because it just thought the DELUA didn't exist. It was looking for it and just couldn't find it, which is weird. It's here. I plugged it into the backplane, but it's looking for it at a specific memory address, and so that got me thinking maybe I should look at the dip switches. It's a little tough to see, but this is the dip switch that sets the base address for the DELUA card here, and it is currently set to off, off, on, off, on, off, on. And if we look at the manual, it says it should be off, off, on, off, on, off, on, off. Now I realize that I said a lot of the same thing over and over again, but this last one here is supposed to be off, and on my card, that one is on. Now I swear I double checked these last week and they were correct, but I've had the card in and out of here so many times, I could have easily hit this with my finger and accidentally knocked it down. But this one right here is supposed to be up like that, so that should be the correct address. The operating system should see it now. So let's give this another shot. I've got my Rainbow 100 spun up here. I'll go ahead and hit T to put it into terminal mode, and then we will turn the power on. Console version 3.40C, program halted at 1/6 business as usual. So we'll do a B space DM here. That's going to start booting from the Fujitsu SMD drive down there. All right, so the date and time I'm actually going to punch in as the real date and time today, which is currently 12:58, and it is 11 AUG 2026. Now RSX 11M Plus here is fully Y2K compliant, so punching in a 2026 date is not going to be a problem. We do want to start DECnet. We do want to start TCP/IP. We don't have a crash explanation to enter. There it goes. Con online all. Just went straight past it. Apparently it found the DELUA. That's excellent news. Okay, so now we're just gonna watch the rest of the boot up process here. All right, there we go. There's our NCP set sys instruction. This one's gonna be a little bit, so I just gotta be patient. Okay, we got through NCP set sys. Okay, so our node state is now on. So far, everything looks all right there. Loading lat process. Circuit up, that sounds good. We did get a collision detect check failed, but Mark has said that that's not terrible to see those. He sees those on his. All right, pushing on with the boot here. Seems that we're getting more stuff. There's ETH ACP and UNA0 DHCP requesting destination 192.168.1.238, set address to, will renew leases in 738 minutes. It's going off the top fast, but I think that means we got an IP address. 192.168.1 is obviously my local network. 238 is something that I didn't assign to anything. It assigned it to this. And it got it from my router. The router DH, this is really cool. Okay, so the ultimate test here is, can I ping an actual website? So I'll do ping, the command ping, which we have installed correctly here, I believe, and we're just gonna do a google.com. Can we ping it? Check that out. Oh man, we're pinging Google. My 1980 PDP 1144 is reaching out into the modern world and listening for replies, and it's getting them. Check that out. Oh man, if we control C out of that, we can see 24 packets transmitted, 24 packets received, 0% packet loss. This PDP 1144 is on my local network, which means it can also touch the internet. How wild is that? This is absolutely amazing. And so the next step, the ultimate goal here, is to be able to transfer files between the 1144 and any other computer on my home network, like my desktop inside or the laptop behind me here. But before we do that, I mean, this is like a precarious nightmare that's just begging for me to trip over it and split my head open on something. So we need to, I need to route, I'm saying we, like you guys are gonna show up and help me route this cable. I need to sit down and route the cable properly behind some stuff and figure out how to get my shorty DECNA cable up there properly mounted and just kind of tidy everything up so that way I don't accidentally kill myself by tripping over it. The original DELUA cable is much longer and goes to a proper bulkhead on the back, but this DECNA cable is all I got. I think I can make this thing mount decently cleanly though by bolting it to the side here. Next step is to run the Ethernet cable from my router, which means I gotta get behind the NCR Computronic. This is where the Wi-Fi router, my serial terminal server, and the Total Access 900E live, which we'll dive into deep one of these days. This is the easy part of the routing though. Everything is exposed and simple to get to. The next part is the tough stuff. I first got to pull the homebrew and drawers out of the way and then get the TI 980 and ASR 33 pulled out of the way. But once those are out of the way, I can then zip tie everything into place and move over to the new desks. I don't want to slide these out, there's too much stuff tangled around them, which means it's time to lay down like I'm working on a car. And finally, once it's all routed cleanly along the wall, I'll bring the cable up and into the 1144 where it plugs right into our MAU. We're all spun up and I believe we're fully connected, so we'll log back in here, we'll do a hello. It's gonna ask me for my account, that's gonna be Usagi. The password is gonna be Usagi. And there we go. Login procedure ready. So if I do a ping google.com, we should see that we are indeed connected, pinging google.com just fine right there. Now, the real thing that I want to do, and the entire reason that we're running down this networking path, is I want to be able to transfer files from the PDP-11 to my laptop or my desktop inside, and from that back down to the PDP-11. I essentially want to be able to connect the two to each other. So right now I've got my laptop set up here, and it's the only cable plugged into it is the power cable. So this laptop is connected to the Wi-Fi in this room, which is then going through a wireless bridge to the house, where it then goes in and connects up to Starlink and goes to satellites. So I want to send a file from this laptop to this PDP-1144. And if I do a quick ls here, you can see we've got a couple of files in here, but the one I'm going to send is story.txt. So I need to connect this laptop to the 1144 via FTP. So I'm just going to run FTP here. It gives me a little FTP prompt, and then I'm going to say open 192.168.1.238. That is the IP address that the router has assigned my PDP-11 here. We actually saw that sling by when it was in the boot up there. So if I do this, it's going to say connected to 192.168.1.238, welcome, and it's asking for a name. So it's asking me to log in. We're going to log in with the same login that I logged in earlier, Usagi and Usagi. And login successful. Remote system type is RSX11M+. This is hyper cool. If I do a directory listing here, we can see the directory is 6,1. That's the user that we logged in as over here. And we can actually see that the PDP-1144 has acknowledged that we've logged in. We see FTP login user Usagi, and it gives the IP address of the laptop. Like, how cool is that? But let's send a file from the laptop over to the PDP-1144 here, and just to prove that that file's not here already, if I do a directory listing, this is 6,1, and you can see story.txt is nowhere in here, right? So let's do a put story.txt, and just hit return on that. There we go. File done, just like that, immediately sent it over. If I do a directory listing on the 1144 over here, we should see story.txt, and I should be able to do a type story.txt over here, and this is the story of a girl who cried a river and drowned the whole world, and while she looks so sad in photographs, I absolutely love her when she smiles. This is such a sad song, but it's one of those, like, when I'm in a good mood, for some reason, this song gets lodged in the old brain case and I can't get it out. And today, I'm in a good mood because we just sent a file from my laptop through the Wi-Fi router to the house, from the house, back over to the 1144, and it all worked perfectly. So in the future, when we get the 1144 hooked up to the Auger electron spectroscope, we can then take spectra file into the 1144, manipulate it, and then send that file to my desktop where I can upload it to the internet or to Wikipedia or share it on Discord. Like, the possibilities are endless. This is the coolest thing ever. I'm absolutely loving this. Massive, massive shout out to Mark for all your help. I made it look really easy, but honestly, it wasn't. There was a lot of RSX11 specific setup that we had to do, and the only way we could do it was, you know, hours on the phone talking with Mark and just figuring it out line by line. But man, this is absolutely epic. I'm having a wonderful day, and I hope all of you guys are having a wonderful day as well. And I want to thank you all so much for hanging out with me, and I hope to see you in the next one.